In question 1, I've got 6 integer values. I need to find A, B, C, and D. I'll start from the fact that the mode is 9, and as you can see, there are 3 D's, hence D is equal to 9. Then I'll use the fact that the median is equal to 8. Now there are 6 integers, so the midpoint of the middle two is equal to 8. Hence, C plus D over 2 is equal to 8. C plus 9 over 2 is 8, which gives me a C of 7. Then I'll use the fact that the range is 4. Hence, D, which is the largest, minus A, which is the smallest, must be equal to 4. A is equal to D minus 4. I found D to be equal to 9. So 9 minus 4 is equal to 5. And I'm missing B. I know that A, B, C, and D are integers. So the only integer between 5 and 7 is equal to 6. Hence, my answer is 5 for A, 6 for B, 7 for C, and 9 for D. For question 2 part A, I need to plot those 3 lines. Now the first one is a horizontal line cutting the y-axis at 1. The second one, x equals 2, is a vertical line cutting the x-axis at 2. And for the last one, either rearrange and get a small table of x and y values or find the x and y intercept. I'll do the second one. So when x is 0, y comes out to be 7. That's the point 0, 7. And when y is 0, substitute this and get x equals 7. So that's the point 7, 0, which means the line passes through this point and this point. Join those using a straight line. Now for part B, to find the required region, I will consider the 3 inequalities. For the first one, y is bigger than or equal to 1. This is the region above the line with the equation y is equal to 1. X is bigger than or equal to 2 defines the region to the right of this line. And finally, for the last one, if you rearrange and get y is less than or equal to 7 minus x, you will notice that this is the region below the corresponding line. So that's the region below the line. So the required region is the region to the right of this, below the diagonal line, above the horizontal. So that's the triangle here. Now, it doesn't matter whether you shade the region that you want or the region that you don't want, as long as you correctly label the region with an R. For question 3, speed is equal to distance over time. Now the distance is 3,980 kilometers and the time is 5 hours and 24 minutes. Now I can convert this as a fraction, so it's 5 and 24 over 60. I can simplify this one to 5 and 2 over 5. I can even turn it into a decimal, which is 5.4. So I will divide the 3,980 by 5.4. Note, if you're going to use a fraction, make sure that you press the correct button on the calculator. There's a mixed fraction button on the calculator. Use that one. So this will give me 737.03 and so on. I need my answer to the nearest whole number, so 737 kilometers per hour is the final answer. For question 4, I'll need to show all my steps, and I'll start with the left-hand side, which is equal to 5 and 1 over 3 minus 2 and 6 over 7. Now the lowest common multiple of the denominators is 21, so the first fraction becomes 5 and 7 over 21 minus 2 and 18 over 21. I can't subtract the 18 from the 7, so I'm going to convert the first fraction into 4 and 28 over 21 minus the second fraction. So 4 minus 2 is 2, 28 minus 18 is 10 over 21, and this is equal to the right hand side as required. For question 5, I'm given that the area of the whole shape is 434. I will proceed by splitting this shape into a rectangle and a trapezium. For the trapezium, the base BE, which is this one, is equal to 28 minus 5 and 5, 10, which means the base is 18. And the height of the trapezium is equal to 20 minus 12, which means it is equal to 8. Now the area of the trapezium is given by the following formula. This is given in the formula sheet on page 2. And now let's use the fact that total area equals area of rectangle plus area of trapezium. So 434 equals to the area of the rectangle. This is equal to 28 times 12, which is 336, plus 1 over 2 a plus b times height. So 98 is equal to 1 over 2, 18 plus x, where x is sin d, times the height, which is 8. I can cancel out the 2 with the 8 and get a 4. So 98 divided by 4 is equal to 24.5, which is equal to 18 plus x. So x comes out to be 6.5, and that's my final answer. For question 6, I'll use the fact that cos of 42 equals to adjacent over hypotenuse, so x over 9.5. So x is 9.5 times cos of 42. Put this on the calculator and you'll get 7.121 decimal place. For question 7, I've got 21 kilometers over 1 hour. Now 21 kilometers, if multiplied by 1,000, will give you meters. And then 1 hour multiplied by 60 will give you minutes, times another 60 will become seconds. And if you put the whole thing on the calculator, you'll get 22.5 meters per second. For question 8, I'll start by adding 7, 5, and 3, which gives me 15. And then for the birthday and anniversary cards, I'll find how many of them I have, and then how many of those have numbers on them. So for birthday cards, I've got 7/15 of 300, and this gives me 140 birthday cards. Out of those, 2/5 have numbers on them, which means 56 birthday cards have numbers. Let's repeat for anniversary cards. I have 5/15 of 300, which is 100 cards. And then out of the 100, 36% have numbers. So a total of 36 cards have numbers. Now 56 plus 36 is equal to 92. That's the total cards with numbers, irrespective whether they are birthday or anniversary cards. And to find the fraction of those cards that has numbers, I'll just do 92 over 300. If I want a simplified answer, this will be 23 over 75. In question 9, I will use the following formula. Final amount equals to the initial amount times the multiplying factor. Now in our case, we have an increase of 1.3%, and this is done for 4 years. So my multiplying factor will be 101.3 over 100 to the power of 4. If you want this as a decimal, it's 1.013 to the power of 4. So to find the final amount, I will have 50,000 times 1.013 to the power of 4. Put this in the calculator and you will get 52,651.14, which rounds to 52,651. For question 10, you have to solve this equation simultaneously. Now you can do that either by using the method of elimination or the method of substitution. I'll proceed with the first one, elimination. I'll keep the first equation the same, so 7x plus 3y equals 3, and then I'll multiply the second one by 3. So I'm gonna get 9x minus 3y equals to 21, and if I add the two equations, I'll get 16x, the y's will cancel out, equals to 24. So x is equal to 24 over 16, which simplifies to 3 over 2. And now I'm going to substitute these into any of those equations. I'll choose this one, 3x minus y equals 7. So 3x minus y equals 7. Let me write it down. 3 times 3 over 2 minus y is equal to 7. If you do the calculations, y comes out to be minus 5 over 2, and this is the final answer. For question 11, part I, the two factors are x plus 8 and x minus 3. Hence, when you solve the equation, the two solutions will be x equals to minus 8 or x equals to 3. For this type of questions, I always like to construct a table for each group of items. So my table will look like this. One row for the sum, one for the number of items, one for the mean, and the columns are 3 parcels, 4 parcels, and the 7 parcels. Obviously, n will be 3, 4, and 7. And now let's transfer the information I have on this table. I have that the mean weight of the 7 parcels is 2.7. I also have that the mean weight of the 4 parcels is 3.3. And for the first 3 parcels, the weight is W for each one, so the sum will be W plus W plus W, which is equal to 3W. Now I will find the sum of the 4 and the 7, and then I'll create an equation where these two sums must be equal to the sum of the 7. So for the sum of the 4 parcels, I'll just do 4 times 3.3. This will come out to be 13.2, and I'll repeat for the last column. 7 times 2.7 is equal to 18.9. So these two numbers must add up to 18.9. That's my equation. So 3W plus 13.2 equals 18.9. 3W equals 5.7. So W is equal to 1.9. For question 13, I'll start by completing the cumulative frequency column. So the first one is 7, then 7 and 25 is 32, plus 20, that's 52, plus 14, 66, plus 8, 74, plus 6, 80. And then to draw the cumulative frequency graph, I'll use the upper bounds as the x coordinates and the cumulative frequencies as the y coordinates. Now, since the lower bound of the first category is 0, then the x-intercept will be 0, 0. That's an extra point on my graph. So if I go on the next page, I will zoom out to fit this in the whole screen. I will plot the coordinates and then I will join them using either a smooth curve or straight line segments. I'll go with the second one. Then for part C, I need to find an estimate for the median. Now note that 80, which is the total frequency, divided by 2 is 40. So I'll need the 40th observation. To find that, let's go again back to the graph. Now I'll start from the y-axis, find 40, come down, and where it intersects the x-axis, that's my median. So from my graph, that is 34 years. Note that the mark scheme accepts any answer between 32 and 34. Now for part D, I'm given that of the people in the train carriage, 60% of those who are aged between 18 and 65 are going to work. And I need to find an estimate for the number of people going to work. Now I'll start by finding the number of people who are between 18 and 65. Now the graph is a cumulative frequency one, so it only works with less than a specific number of years. So I'll find how many are less than 65 years. Then I'll find how many are less than 18 years. And if I subtract those numbers, I'll get the number of people between 18 and 65. So let's go to the graph again, zoom out, and then I'll do the reverse that I did in part C. I'll start from the x-axis at 18 and 65 and then find the corresponding y values. So from the graph, I see that these values are 6 and 77. So that's 77, that's 6, and if I subtract, I'll get 71. So there are 71 people between 18 and 65. Now 60% of 71 people are going to work. This is 42.6. So approximately 43 people are going to work. The mark scheme accepts answers of 42, 43, or 44. The answer must be an integer value. For part A of question 14, I will keep the first bracket the same and I will expand the other two brackets, so I get 2x squared plus 8x plus 3x plus 12. Now I'll simplify this. 5 minus x, and the second bracket becomes 2x squared plus 11x plus 12. And now I will expand these two brackets. 10x squared plus 55x plus 60 minus 2x to the power of 3 minus 11x squared minus 12x. And if I collect like terms, I will get minus 2x to the power of 3 minus x squared plus 43x plus 60. And that's the final answer for this part. For part B, I'll start by bringing the minus 7 to the left. So I get g plus 7 equals to c plus 3 over 4 plus c. Then I will cross multiply, so g plus 7 times 4 plus c equals to c plus 3. Let's expand the left hand side. 4g plus cg plus 28 plus 7c equals to c plus 3. Since I want to make c the subject, I will collect all c terms on one side. So I'll take these two terms on the right. I'll bring the 3 to the left. So I get 4g plus 28 minus 3 is 25 equals to c minus cg minus 7c. I can simplify the right hand side. So 4g plus 25 is equal to minus cg minus 6c. And then I will factorize the right hand side. 4g plus 25 is equal to c minus g minus 6. And now I will divide by the bracket. So 4g plus 25 over minus g minus 6 is equal to c. Note that I will multiply both top and bottom by minus 1. So c will come out to be minus 4g minus 25 over g plus 6. The mark scheme accepts both of these versions. For question 15 part A, I will find the lowest common multiple of the three denominators, the 3, the 2, and the 1 here over the 13, and the lowest common multiple is 6. So I'll multiply the first fraction by 2, the second one by 3, and the right hand side by 6 to make the denominators the same. So 2 times 4x plus 5 minus 3, 3 minus 2x equals to 13 times 6. There is no need to write the denominators as they will cancel out. So if I expand now, I'll get 8x plus 10 minus 9 plus 6x equals to 78. Collect like terms. So 2x plus 1 equals 78. 2x equals to 77. So x is 77 over 2. For part B, I will first factorize. So 2y plus 5 times y minus 6 is less than or equal to 0. The two critical values or roots are y equals to minus 5 over 2 or y equals to 6. Now this is a quadratic, positive quadratic, and I will make the horizontal axis. Note that because I have y's and not x's, my horizontal axis will be the y-axis. And here is the graph. Now this graph cuts the axis at minus 5 over 2 and 6. and I want this graph to be less than 0, which means I want it to be below my axis. And this happens for values of y between -5/2 and 6. So -5/2 less than or equal to y less than or equal to 6 is the final answer. For question 16, I'm given this information and I need to complete the Venn diagram. I will start with the middle region, the triple intersection, and this is equal to 6 because there are 6 farmers that have goats, sheep, and chicken. So this 6 goes in the middle. And then I'll have a look at the double intersections. I have these 3. So 11 have sheep and goats. So sheep and goats are these 2 regions together. This should be 11. I already have the 6, so the top one is 5. Sheep and chicken, I have 17. Sheep and chicken are these 2 regions. 6 plus 11 equals to 17. And finally, 18 goats and chicken. So these 2 regions should be 18. 6 plus 12 gives me an 18. I'm also given that 20 do not have any of those 3, so the region outside the circles is 20. 31 have sheep, so the whole circle for the sheep should be 31. So 31 minus 5, 6, and 11 will give me a 9. And similarly, 53 have chicken, so 53 should be the sum of these 4 regions. So 53 minus 12, 11, and 6 will give me 24. And there's one region left. I'm going to use the fact that everything is 100. So 100 minus the rest will give me this region, which is 13. For part B, the n in front of the sets shows that I need the number of elements. So NG needs the number in circle G. Add those 4 numbers and you'll get 36. For part I have n of G union S dash. Now G union S is the region in either G or S or both. So we're talking about this region. So the dash outside means everything except those, which means I need the 24 and the 20. So this gives me 44. And for part 3, n of G dash intersection C means I need the region that is inside C but outside G. So the C without the G is this region here, which is 24 plus 11, which gives me 35. Finally, for part C, it says one of the farmers who has chickens is chosen at random. So if I go to my diagram, I have in total 53 farmers with chicken. So my denominator will be 53. And I want the probability that this farmer has also goats. So out of those 53 farmers, which ones have goats? And the answer is these 2 regions here. So 12 plus 6. So the final answer is 18 over 53. For question 17, I'm given that m is proportional to the cube of h. So m equals to kh to the power of 3. Let's substitute the values we have in. So 4 equals to k 0.5 to the power of 3. So 4 over 0.5 to the power of 3 is equal to k. K comes out to be 32. So the formula is m equals to 32h to the power of 3. I'm given that m is 500, so 500 equals 32h to the power of 3. 500 over 32 equals to h to the power of 3. H is the cube root of 500 over 32, and this comes out to be 5 over 2. For question 18, I'll start by finding upper and lower bounds for A, B, and F. A is between 7.45 and 7.55. B is between 3.415 and 3.425. And F is between 1.5 and 2.5. Now, to find the upper bound of this fraction, I'll need the upper bound of the numerator over the lower bound of the denominator. And because the numerator is a difference, I'll need the upper bound of the first number minus the lower bound of the second one. And for the denominator, I'll need the lower bound. Hence, I'll need the upper bound of A and the lower bounds of B and F. So let's substitute. 2 times 7.55 minus 3.415 all over 1.5. Put this on the calculator and you'll get an answer of 7.79, and this is my final answer. For question 19, I'll need to replace the x here with this expression. So A equals to 14 all over 3 times 7 over 4y minus 3, close bracket, minus 7, which is equal to 14 over, and then I'll have 21 over 4y minus 3 minus 7. Now let's focus on the denominator of this fraction. So I get 21 over 4y minus 3 minus 7 over 1. So I'll need to multiply the second fraction by 4y minus 3. This will give me a single fraction with denominator 4y minus 3, and the numerator will be 21 minus 7, 4y minus 3. Let's simplify this. 21 minus 28y plus 21 over 4y minus 3, which is equal to 42 minus 28y over 4y minus 3. Hence, the value of A is now 14 over 42 minus 28y over 4y minus 3. You might find this easier if I write it as 14 divided by 42 minus 28y over 4y minus 3, because now I can flip the second fraction and change division to multiplication. So I get 14 times 4y minus 3 over 42 minus 28y. I will factorize the denominator, so I get 14 times 4y minus 3 over 14, 3 minus 2y, so I can cancel out the 14 and I'll be left with 4y minus 3 over 3 minus 2y. Note that the mark scheme also accepts minus 4y plus 3 over 2y minus 3. For question 20, let R be the radius of the circles. Hence, the side of the square is equal to 4R. Now I'm going to use the fact that the shaded area is equal to the area of the square minus the area of the 4 circles. So 40, which is given, is equal to 4R all squared minus 4 times the area of a single circle, which is pi r squared. So 40 equals 16r squared minus 4 pi r squared. I will factorize the r on the right hand side. So 40 equals to r squared 16 minus 4 pi. I'll take the bracket to the other side with division. So 40 over 16 minus 4 pi equals to r squared. So r is the square root of this fraction. This comes out to be approximately 3.4131 and so on. Hence, the perimeter is 4 times the side, so 4 times 4r, which is equal to 16r. And if you substitute the 3.4131 into 16r, you'll get 54.6 to 3 significant figures. I will start question 21 by indicating AP on my diagram. Next, note that AQ, which is this one, is a fraction of AB. Let's call this fraction lambda. So if AQ is lambda of AB, then QB is the rest. That's 1 minus lambda of AB. Now similarly, OQ, which is this one, is a fraction of OP. Let's call this fraction nu. Thus, QP, which is this one, is the rest. That's 1 minus nu. The idea is to find a start and end point and find two different routes. We are not interested in the journey, we are interested in the destination. So the two vectors for this journey must be identical because they start and end at the same point. So for example, consider AQ. There is the direct approach from A to Q, indicated with this green line. And there is another approach, for example, from AO and then OQ, indicated with this purple line. So let's find the vector for the direct AQ. So AQ is equal to lambda times AB. Hence I've got lambda, and AB now is equal to AO plus OB. This is lambda, and AO now is minus 4a because I'm going OA in the reverse direction. So minus 4a plus OB, which is equal to 6b. And if I expand, I'll get minus 4 lambda a plus 6 lambda b. And now I'll find AQ using a different journey. I'll use the purple one. So to find AQ now, I'll go from A to O and then from O to Q. Now AO is minus 4A and OQ is a fraction of OP. That's mu times OP. So I'm going to rewrite the first part, minus 4a plus mu. And now I don't know OP, but I do know that it is equal to OA plus AP. Hence, minus 4a plus mu. And now OA is 4a plus AP, which is 2a plus 8b. Let's simplify this. Minus 4a plus mu, and then the bracket simplifies to 6a plus 8b. I will expand so I can separate the a's with the b's. Minus 4a plus 6 mu a plus 8 mu b. And now I'm going to separate the a's. I have a bracket minus 4 plus 6 mu plus 8 mu times b. Now, because the AQ on the left must be equal to the AQ on the right, then the coefficient of A, which is minus 4 lambda, must be equal to the coefficient of A on the right, which is this one. And similarly for the B's, 6 lambda must be equal to 8 mu. So now I have two simultaneous equations to solve. Starting with the red one, I get 6 lambda equals to 8 mu. So mu equals to 6 over 8 lambda, or if I simplify, 3 over 4 lambda. And then I have the blue equation, which is minus 4 lambda equals to minus 4 plus 6 mu. And I'm going to substitute the 3 over 4 lambda into mu. So I get minus 4 lambda equals to minus 4 plus 6 times 3 over 4 lambda. Let's simplify. Minus 4 lambda equals minus 4 plus 9 over 2 lambda. I'm going to take the minus 4 lambda to the right and the minus 4 to the left. So 4 equals, and if you add 9 over 2 lambda and 4 lambda, you'll get 17 over 2 lambda. And to find now lambda, I'll just divide 4 by 17 over 2, and this will give me 8 over 17. So to find the ratio AQ to QB, let's go back to our shape. AQ is this one, QB is this one, so the ratio is lambda to 1 minus lambda. So lambda to 1 minus lambda gives me 8 over 17 to 9 over 17. If you multiply this ratio by 17, you will get 8 to 9, which is the final answer. For question 22, I'll start by doing a rough sketch of the kite. Point A has coordinates minus 3, 4. Point B has unknown coordinates x, y. Point M has coordinates 0, 2. Note that this is not the correct orientation, but at this point it doesn't really matter. I will work with triangle ABM, and I will use the following formulae. Now, triangle ABM is a right angle triangle, which means two things. AM is perpendicular to BM, and second, Pythagoras theorem holds. I'll start using the lengths. I'll find the lengths of AM, BM, and use the 6.5 to form Pythagoras theorem and have an equation. So let's begin. AM equals to the square root of minus 3 minus 0 squared plus 4 minus 2 squared. This simplifies to square root of 13, and BM is equal to the square root of x minus 0 squared plus y minus 2 squared. This simplifies to the square root of x squared plus y minus 2 squared. So now, using Pythagoras theorem for that blue triangle, I have AB squared equals to AM squared plus BM squared. So 6.5 squared is equal to 13. Square root 13 is 13 plus BM squared. Now if you square this number, this square root will cancel out. So I get x squared plus y minus 2 squared. Now if I evaluate this one and take the 13 to the left, I will get 117 over 4 equals to x squared plus y minus 2 squared. And this is my first equation, equation 1. For my second equation, I will use the gradients of AM and BM and the fact that they are perpendicular. So the product of the gradients is minus 1. So gradient of AM equals to 4 minus 2 over minus 3 minus 0, which gives me minus 2 over 3. And the gradient of BM is equal to y minus 2 over x minus 0. And now if I multiply those two, I should get minus 1. So minus 2 over 3 times y minus 2 over x is minus 1. So minus 2y plus 4 over 3x equals minus 1. So minus 2y plus 4 equals minus 3x. Let's get y on its own. So 2y on the right, 3x plus 4 on the left, which means y equals to 3 over 2x plus 2, and that's my second equation. So now to solve simultaneously equations 1 and 2, I'll just substitute y here with 3 over 2x plus 2. So 117 over 4 equals to x squared plus 3 over 2x plus 2 minus 2 squared. The minus 2 with the 2 cancel out, so I've got 117 over 4 equals x squared plus 9 over 4 x squared. So 117 over 4 equals to 13 over 4 x squared. If you add 1 and 9 over 4, you get 13 over 4. So x squared is 117 over 4 divided by 13 over 4, and this gives you 9, which means that x equals to plus or minus 3. Now, if x is 3, then y comes out to be 6.5, and if x is minus 3, then y comes out to be minus 2.5. So point B is the one with the positive x coordinate, 3 and 6.5. Point D is the other one, minus 3, minus 2.5. Now the question asks for points B and D, didn't say distinguish between the two, so writing which one is which is not necessary. To answer question 23, I'll start by considering the graph of y equals cos x. I'll sketch this down here. Now this graph first cuts the x-axis at 90 and has a minimum point at 180 minus 1. In the question, I'm given the sketch of the graph of y equals cos of x over 2, and this is a stretch along the x-axis by a scale factor of 2. So to find a and b, I will multiply the x coordinates before the stretch by 2 and keep the y coordinates the same. So to find a, I'll start with 90, multiply this by 2, becomes 180, y coordinates stay the same. Similarly for b, it used to be 180. If you multiply 180 by 2, you get 360, and the y coordinate stays minus 1. I'll start question 24 by simplifying the 6 with the 18. I get 3 and 1. And then I'll do some side work for this expression here, the root 27. Remember, the target is to change everything as a power of 3 because this is what the right-hand side tells us. So square root of 27 can be written as 27 to the power of 1 over 2, and 27 is 3 to the power of 3. So 3 to the power of 3 all to the power of 1 over 2. And now if I multiply those powers, I'll get 3 to the power of 3 over 2. Also note that 9 can be written as 3 to the power of 2. So if I continue, I will now get 3 to the power of 1 times 3 to the power of 3 over 2 and all to the power of 4n plus 6. And for my denominator, I will get 3 squared to the power of 2n plus 8. So now I can multiply these two powers and these two powers together. So I will get 3 to the power of 1 times 3. Now for the multiplication, if you want, you can use the calculator. The power will be 6n plus 9. And then in the denominator, I will get 3 to the power of 4n plus 16. Next step is to join these two powers, and this will be done using addition. So 3 to the power of 6n plus 10 over, and the denominator stays the same for this step. And then finally, because I have division, I will subtract the powers. So this will give me 3 to the power of 2n minus 6. Hence, final answer x equals 2n minus 6.